Hello students. Today I'm going to start with one of the sub-modules of chapter 5 of machine learning. The module name is classification and the sub-module name is Bayesian belief network. Before going to Bayesian belief network, there is a type of classification called as rule-based classification. As you all know, when we had solved numericals on classification by using decision tree and ID tree, we have seen how we generate a decision tree and we use the if-else condition. So, rule-based classification is nothing but if-else type of classification. The next type of classification that we have is Bayesian belief network. So Bayesian belief network is nothing but a directed acyclic graph. Okay, so before understanding the concept of Bayesian belief network, you are supposed to know what is a directed acyclic graph. DAG, it is nothing but a convenient way of representing probabilistic relation between multiple events. So if you see this DAG, we have considered three nodes: rain, dog, bark, and cat, hide, where the main node of consideration is dog, bark. As you can see, it is highlighted with an arrow. The node which is above the considered node is called as the parent node, and the node below the considered node is called as the child node. So basically, a dog barks only when it is raining. So this is how it is represented. So dog barks given that it rains. Whereas the second instance shows the cat hides when the dog barks. So this is your directed acyclic graph. Now you must be wondering why I am teaching these topics is because these are the prerequisites for understanding Bayesian belief network. Now, this Bayesian belief network can be the directed acyclic graph can be converted into a conditional probability table. So if you see over here, this is just a random example taken where R represents for rains. Negation of R means it doesn't rain. Similarly, B stands for bark, that is the dog barks, and negation of B implies the dog doesn't bark. So if we try to understand the learning from the table, if the dog barks is true and the rains is true, that is 9 by 48, then the value is nothing but 0.19. Similarly, you can try it for others. These values are completely just taken for example and understanding purpose. Now, coming to the actual concept of your Bayesian belief network model. A Bayesian belief network problem looks like this, where you have got a directed acyclic graph and each of these nodes have got the conditional probability table. So if you see, the considered node over here is alarm, and we have got the parent node, that is burglary and earthquake, and we have got the child node, John calls and Mary calls. So basically, I'll brief you the situation of this particular problem is that there is a person and He basically goes out and there is an alarm that has been present in that person's house. That person has two neighbors, John and Mary. So the person tells John and Mary to call when the alarm rings. The alarm can ring in two situations: if there is a burglary, that is a theft, or if earthquake occurs. And each of the conditional probability tables are given to you. So, how do you get a problem where we can apply Bayesian belief network is the question given to you will be John calls to say alarm is ringing. So John will call to that respective person to tell him that alarm is ringing. Mary also calls to say that alarm is ringing. Alarm did ring, but there was no earthquake or burglar. Find the probability of such a scenario. So if we want to represent this particular question in a mathematical format, it will be in this form. John calls to say alarm is ringing. So it is denoted by J. Mary calls to say alarm is ringing is denoted by M. Alarm did ring denoted by A. But there was neither earthquake nor burglar. It means negation of B and negation of E respectively. So in this case, what is going to be the scenario? So John called when the alarm rang. So it is probability of John calling when an event occurs, that is when the alarm rang, multiplied with Mary calling when the alarm rang, multiplied with the alarm rang, but neither earthquake or burglary happened. And this is going to be negation of B and negation of E because both the things or events didn't occur. So probability of John calling when the alarm rang. How do you find this? If you look at the table. John calling when the alarm rang. So it is true and the alarm also rang is true. So it is 0.90 as you can see over here. Mary calling when the alarm rang. So Mary calling when the alarm rang is your 0.7. Similarly, alarm rings, but there is neither earthquake nor your burglary. So we'll go to the alarm table. So what will happen? There is neither earthquake, okay, and there is neither burglary. So both are false in this case. So basically what will happen in that case over here? This is basically for your 0.01 and 0.999. Okay, because what is happening over here, the alarm rings, but we are considering the negation. So that is why we consider the false condition and the respective values under the false condition. Then negation of your B, which is 0.999, and negation of your E 0.998, and you multiply and you get the probability of such a scenario. You can try out for the second question by yourselves. Now, coming to the next part you have got is your hidden Markov model. But before understanding hidden Markov model, it is important for you to study what is a Markov model. So, a Markov model is nothing but you have got a set of states. You might have studied what are states in your TCS, Theory of Computer Science. So a Markov model is a set of states S1, S2 to your S of n. And the process moves from one state to another where we generate a sequence of your states. So basically, what is this Markov chain property? It is nothing but the probability of each subsequent state. Subsequent is nothing but the next state depends only on what was the previous state. So if you see the equation over here, P of Sik is nothing but the current state, but it depends upon the sequence of the previous state, that is S of Ik minus 1. Alright, your initial, to define Markov model, the following probabilities have to be specified. So transition probability is denoted by your P of your Si, which is nothing but the current probability by your previous probability, that is S of j, and initial probability is denoted by your pi of I. Transition probability is denoted by your Aij and initial probability is denoted by your pi I. So if you see the Markov chain model, this is nothing but a set of states S1, S2, S3, S4, where S1 is nothing but the initial probability. And what you can see in your red arrows is nothing but the transition probability. Alright. Now let us see first an example of Markov model. So this is basically your state transition diagram that is given where you have got two states, rain and dry. And the transition probabilities are given to you. That is probability of rain given that the rain occurs is 0.3. Similarly, probability it is dry. Previously rain occurred. So dry and rain. So basically this is the current state and previous state what happened, it rained. So it is 0.7. Probability of rain by dry is 0.2 and probability of dry by dry is 0.8. They will be giving to you the initial probabilities of both the states, rain and dry, which is 0.4 and 0.6. Now, this is nothing but the Markov chain property which I explained to you all. It is nothing but the probability of state sequence is found by this formula, that a particular event occurs depending upon the previous events. So if you see over here, calculate a probability of the following sequence. So basically we want to find out the probability of dry, rain and rain. So how do we find out this? Is nothing but we start from your backtracking. So in this case, you will first calculate probability of rain depending upon the previous event, which is nothing but rain, multiplied with rain, the previous event dry, probability of your dry divided by your dry, and finally your dry. It's very simple. Find out probability of rain given that rain has already occurred. Rain, initially it was dry, initially it was dry, multiplied with probability of dry. These values you will be getting from the table that will be given to you over here, and the final value is displayed over here.